resistance. Is it forcible? So this will not be forcible. This must be what? This must be off, because this 1.2, it is more higher than what? Than this 0.7, and this 0.7, it is more less than this 1.2. So therefore there is no possibility of this what? Of this gallium arsenide to be on. So therefore this gallium arsenide what? This gallium arsenide diode, it is what? It is off. You are just going to concentrate on this diode, which is what? Which is on. After then, you're going to apply the KVL, move here, and move off to here to find your currents. And therefore, if you are going to find voltage as usual, move to what? Move to here. So how can I find this? So let me use the drop, negative to positive, which is what? Which is dropping, and positive to negative, which is what? Which is rising. So I have to say this is, when this is dropped, the rest will be what? Will be rising. So therefore plus the 0.7 the diode, and therefore plus what? Plus 4.7 what? ID should now be equals to 0. Minus this plus what? Plus then I'll end with minus what? 11.3 plus 4.7 what? 7 ID should now be equals to 0. So I have to have 4.7 what? ID. This should now be equals to, when the negative 11.3 cause the equal sign, it will now be what? 11.3. So if I divide both sides by what? 4.7 by 4.7, 4.7 will cancel 4.7. So therefore the diode current should now be equals to 11 divided by the value of what? Divided by the value of 4.7. What should I get? So let me check. 11.3 divided by 4.7. So this should now be what? The current should now be 2.4 watts. Because of this kilo, it is what? Milliamps. You have to understand, if you are using the kilo, it will